Okay, so on today we are on page 45, so go ahead and if you haven't already, turn to page 45 in your book. And today's topic is about determining if a graph is proportional or non-proportional. So you just took the test yesterday on tables, and today we're moving on to graphs. So before I show you how to look at a graph and see if it's proportional or not, there are a few words that you see in yellow that's going to be super important that you know. And I feel like most students think that they just know everything about graphing, but then they mess stuff up. So I do want to take a second and go over these 4 words and review how to graph, because again, I feel like a lot of students think that they know, because it is pretty easy, but then they do things backwards, which makes you get a wrong answer. So, real quick, whenever you hear the word coordinate plane, which is your first word here, that is just talking about the 4 boxes that you will see down below. This is a coordinate plane. Okay, all 4 of these together are your coordinate plane. So, in your coordinate plane, you have 4 quadrants. What that means is, first I want you to notice this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So notice it actually goes counterclockwise. It makes a C. It doesn't go clockwise. And basically, when you get to higher math classes in 8th grade, 9th grade, and on, you're going to learn that in quadrant 1, the only numbers that are in this part of the coordinate plane are positive numbers, because I could graph, for example, 1, 2. I would go over 1 up 2. Both of those are positive. There are no negative numbers right here in quadrant 1. In quadrant 2, you can start to see some negative numbers on the x-axis. But your y-axis is always going to be positive in quadrant 2. Quadrant 3, you start seeing negative and negative. Only negative numbers exist. And then finally, quadrant 4, you have positives and negatives. So, going back, that's a coordinate plane, all 4 of those quadrants together. So I just covered quadrants. So again, quadrants, quad, Q-U-A-D, means 4. If you think of quadruplets, that's 4 kids at a time. So quadrants are just 1, 2, 3, 4. And then your next word is ordered pair. So this, for example, is an ordered pair. It tells you where a dot or point will go on a graph. And I want to remind you that the first number is always the X in an ordered pair, and the second one's always a Y. I always think of alphabetical order. So this is important that you know this, because if you try to graph an ordered pair, you need to know to go over first and then go up or down. Because on the, going back to the coordinate plane, this is your x-axis. So if this is an x, you have to find 1 on the x-axis first, and then find 2 on the y-axis. If you reversed it, which is what a lot of students do, they try to go up first and then go over, and that gets confusing. You need to go in order, alphabetical order. So go over first because you're on the x-axis and this is an x. And then go up. Don't do it backwards. Don't try to go up and then over. You will mess things up. So always, 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 you want to write this down. Go over and then go up or down. Okay? And then finally, x-coordinate just is literally, if I'm talking about x, that's an x-coordinate. And if I'm talking about y, I'm talking about a y-coordinate. So that just means, are they on the x-axis or are they on the y-axis? So for example, this 1 is because of this 1, which is an x-coordinate. This 2 is because of this 2, which is a y-coordinate. Okay, so those are the 4 main words that you need to know. Going down to, okay, so the last part of your quick review on graphing is this part right here. It says graph the points 2, 3, and -3 and -2 above, and then connect the 3 points, so this point plus these 2, on the coordinate plane, and then describe the graph. So go ahead and practice this. See if you can put these 2 points on the graph. Again, I said, oh, I know this is easy for a lot of you, but some of you are going to do it backwards. So pause, try to graph these 2, and then you're going to connect all 3 dots, this dot, and this dot. Come back when you have it done. So this is the point 2, 3. So go over to 2, go up to 3, put your dot, and this is the second point. So we went over to -3 and down to -2. And then finally, I have not connected my 3 points yet because it's going to be hard for me to do that on my Mobi, but I will give it a go. When you connect them, you should see that it makes a straight line. Okay, go ahead and flip to the next page. Now we're going to look to see how we can figure out if a graph is proportional or not. So it says another way to determine whether 2 quantities are proportional is to graph them on the coordinate plane, and if the graph of the 2 quantities is a straight line through the origin, then the 2 points are proportional. So in order for it to be proportional, it has to have 2 things. One, it has to go through the origin, which is the point 0, 0, and it has to be straight. So if your graph does these 2 things, then it's proportional. If you haven't taken a second to write this down, write this down. Because this is going back to, is it proportional or not proportional? I want you to know how to tell if it's proportional or not. So real quick, origin, we didn't talk about that word. The origin's right here, right in the middle. It's the points 0, 0. Okay. So coming back, the next thing I want to talk about is right here, linear relationships. So this word has line at the front of it. Some people mispronounce it incorrectly and say liner, but liner helps you figure out what the word means. So linear relationships are when a graph makes a straight line. So for example, if this is my graph, this is a linear graph. If this is my graph, this is non-linear. So super easy word, linear, non-linear. And so the reason that we're talking about linear is because if you go back up, we said proportional graphs have to make a straight line. So they have to be linear. So go ahead and read example 1, pause this video, read example 1, and then come back to, we're going to talk about it. So on this problem, the first thing that they did is they took their problem and created a table, which is essentially what we were doing in the last section. So they already created their table. Now they are graphing their table. So they said 0, 0, done. Then they went back, 1, 6, graphed it all the way until they had all their points. Now, again, the only way that you have to check to see is this proportional is if it does these 2 things. It has to do both. So the first thing, does it go through the origin? So we're going to check. This is the point 0, 0. It's touching 0, 0, so it does that. And then second, is it a straight line? And in this case, it is straight. So it does those 2 things, so it is proportional. Go ahead and pause this video. Try the got it problem. Graph your chart, see if it's proportional, and then come back to check. Okay, so before you can graph this, you need a table. And notice they didn't give you a table because you learned how to do tables last week or for your last test. So on this one, in order to get your points, you had to create your own graph. And so the way that we did this is it told us that James earns $5 an hour. That means I'm comparing hours and money. So in 1 hour, he's making $5. In 2 hours, he's going to make $10. 3 hours, $15, and so on. So you really only need 3 points. I did 4 just to kind of prove my point here. But after you've done that, again, I'm not going to try to connect it, but it's probably easier for you in your book to connect them. You can see it's going to be a straight line. But let's say you're like, oh, I don't know, I can't draw very straight. Is it supposed to be straight? I don't know. I can't really tell. You can always go back and answer these 2 questions. Right now, my line is not touching the origin because I don't have anything right here. But go back to the question. The only reason it's not on my graph is because I didn't put it in my table. So go back and think about it. If James earns $5 an hour for babysitting, if he works 0 hours, he's not going to earn any money. He's going to earn $0. So there would be a point here. So does it go through the origin? Yes. And is it straight? Yes. If you're not sure if it's straight, look at your points. 5 divided by 1 is 5. 10 divided by 2, 5. 15 divided by 3, 5. 20 divided by 4, 5. Now notice this isn't going to equal 5. But we don't count it because it's necessary for it to be, for the origin to be on the graph. So remember, that's one of the things it has to do. It has to have the point 0, 0. So this one doesn't count when you're finding your equivalent ratios or your unit rate. Now the last thing I want to talk about on this question is some of you would probably ask me, does it matter if I put hours with the x-axis or can I put hours with the y-axis? And it does matter. So I wanted to talk about that for just a second. On this question you can see the x-axis says time, hours. On the y-axis it says amount, money. So you need to make sure that you match those up. We're going to talk more about how they figured out X and Y later, but right now you just need to know that that is important. Okay, go ahead and read over example number 2 and then come back after you've read it for yourself, and I'm going to talk about just a few things. So on this problem, they walked you through. They took the table up here. They plotted the points, so you can see where they plotted them. And then finally they looked at 2 things. Again, they looked at the origin, and they saw there is not a point there. And it is a straight line, but again, it has to have 2 things. It has to touch the origin and be straight, so this would be non-proportional. Also, you can see here, they checked it to see if the ratios are constant. So for example, they went back to this table and they said, okay, this equals 3 because 3 divided by 1 is 3. 5 divided by 2 is 2.5. So these don't match. So that's my other way to know that this is non-proportional. On this got it problem, go ahead and pause the video, try this problem, come back to check it. Okay, so on this problem you should have gotten non-proportional. And this one's kind of tricky, so I'm going to talk you through it. So they took the graph, or the table, and they graphed it. And then they checked, does it touch the origin? Yes, it did. Is it straight? It looks straight. And then they checked the ratios. So sometimes we know that we can't all draw perfectly straight every single time. Just, it's our error, not necessarily something wrong with the graph, just our error. So, if you're not sure if it looks straight, again, check your points. Remember, 0, 0 is okay. It doesn't count, so check the other ratios, see if they're equivalent. 1 goes inside of 4 times. 2 goes inside of 8 4 times. But 3 doesn't go into 13 exactly 4 times. I came over here and divided. I got 4.3, so that makes this non-proportional. On the following page, read over example 3. And then I want you to try problems 1 and 2. And we're going to start there on Monday. So again, solve those 2 problems. Be ready for Monday.